In this lecture, we prove that 1 upon x derivative of error function of complementary of error function of x with respect to a, which is equal to minus 1 upon a derivative of error function of x with respect to x. So we have to first differentiate the complementary of error function of x with respect to a and error function of x with respect to x. So error function and complementary of error function of x are given by error function of x is equal to 2 upon root pi integration under the limit 0 to x e to the power minus u square du, and error function of complementary of x is 2 upon root pi integration under the limit x to infinity e to the power minus u square du. So let us replace error function of x by ax and also the complementary error function of ax by ax. So only this will change, nothing will change over there and also over there. Let us try to take the left hand side. Using DOIS rule or Leibniz rule, we have left hand side which is given by 1 upon x derivative of error function of complementary error function of ax with respect to a, which is equal to 1 upon x, and we have to use this formula, this one, 2 upon root pi, 2 upon root pi, and then integration under the limit ax to infinity, derivative of e to the power minus u square with respect to a, because we have to differentiate with respect to a, with du plus, what is the upper limit? Upper limit is infinity, so derivative of upper limit infinity with respect to a, and the function value of this function e to the power minus u square at infinity, so it is e to the power minus infinity, minus derivative of the lower limit with respect to a, and the functional value of this function at u is equal to the lower limit, which is ax. So again 1 upon x, 2 upon root pi. Since this is free from a, so its value will be 0, and derivative of constant is also 0, so the second part is also 0, minus derivative of ax with respect to a is x, and e to the power minus a square x square. And if we simplify it, minus 1 upon x into x e to the power minus a square x square. So this x and x will cancel. So we have 1 upon x derivative of complementary of error function of x, which is equal to minus this, the 2 is, there is a 2 also. So minus 2 e to the power a square x square upon root pi. This is the first, the value of the first part. Let us try to solve the second part also. So we should get the same result, then our result will be proved. Again, using DUIS rule or Leibniz rule for the second part, minus 1 upon a d dx or derivative of error function of ax. So we again use the DUIS rule, minus 2 upon root pi, because its value, we know that error function of ax, which is equal to 2 upon root pi 0 to ax e to the power minus u square du. Okay, so now the first thing is minus 2 upon a root pi. We have taken this 2 upon root pi. Integration under the limit 0 to x. Derivative of with respect to x, because we want to differentiate with respect to x. So derivative of partial derivative of e to the power minus u square with respect to x du plus derivative of upper limit. Upper limit is ax over here with respect to x, and functional value of e to the power minus u square at ax, so it can be written as e to the power minus a square x square minus derivative of lower limit into e to the power 0. the function value of e to the power minus u square at lower limit. Now, if you simplify, what is the derivative of e to the power minus u square with respect to x? 0, because it is free from x. Its value will be a e to the power minus a square x square, and this will also become 0. So minus 2 upon a root pi, 0, a e to the power minus a square x square minus 0. Now this a and a will cancel, and we have minus 2, this a cancel, minus 2 e to the power minus a square x to the power 2n root, not 2n, it is only 2, n is not over there. So therefore, minus 1 upon a derivative of error function of ax with respect to x, which is equal to minus 2 e to the power minus a square x square upon root pi. So if we compare with the equation number 1 and 2, we have 1 upon x derivative of error function of complementary of x with respect to x, which is equal to minus 1 upon a derivative of error function of x with respect to a, not x. This is a and this is x, which is equal to minus 2 e to the power minus a square x square upon root pi. And this is our answer. Thank you.